Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, today we are starting one more exercise 11.4 of surface areas and volumes, class 10th. So let's have question number 1. Question number 1 says a drinking glass is in the shape of a frustum of a cone of height 14 centimeter. We have a drinking glass which is of the shape of a frustum of a cone. Let me draw a figure for this. Just like this. This is a drinking glass. Drinking glass which is of the shape of a frustum of a cone. For the frustum of a cone, you can refer to the introduction part where we have discussed what actually the frustum is. It is nothing but when we have a cone, if the apex of the cone is cut off like this, and you'll get a figure that is a frustum of a cone. Now, a drinking glass is of the shape of a frustum of a cone of height 14 centimeter. So here, our height is 14 centimeter. This is the height of this glass. The diameters of its two circular ends are 4 centimeter and 2 centimeter. We know frustum has two diameters, the upper part and the lower part. So, upper diameter is 4 centimeter. The diameters of two ends, yes, so it's 4 centimeter. This is the diameter, the larger diameter of the frustum, and 2 centimeter is the lower one. The diameters of its two circular ends are 4 centimeter and 2 centimeter. Find the capacity of the glass. So you need to find the capacity of this glass. And you know the capacity is nothing but the volume of this glass. Let us try to do it. Here, D1, the larger diameter, that is treated as D1 usually. So D1 of glass, that is D1 of frustum, and that is 4 centimeter, which implies that R1 of glass, that is equal to R1 of frustum, and that is equal to 4 divided by 2, that's 2 centimeter. Then D2, the lower diameter, D2 of glass is nothing but D2 of frustum, and that is 2 centimeter, which implies that R2 of glass is equal to R2 of frustum is equal to 2 divided by 2, that is 1 centimeter. So we have both the radii, upper radii that's 2 centimeter and the lower radii that's 1 centimeter. Also height is given, the height of glass, that is the height of frustum, yes, that is equal to 14 centimeter. Got it? Now we need to find the capacity. So we know the formula for finding out the capacity or the volume of a frustum. Since volume of frustum, we know the formula. By the formula table, we know it's 1 by 3 pi h times R1 square plus R2 square plus R1 R2. That's the formula for finding out the volume of a frustum. is equal to, now put the values in, 1 by 3 times, now you can treat pi as 22 by 7, nearest rational number value for pi, then times h, h is the height and height is 14 centimeter, times r1 2, then square, plus r2 1, then square, plus r1 r2, that's 2, times 1. Going further, now we can solve this like 7 ones, 7 twos, 14. So we have 22 times 2, that is 44, divided by 3. Then in brackets we have 2 ones 2, plus 1 3, 2 twos 4. So 4, 5, 6, 7. So it's 7 like this. Now we can go further. 2 twos 4, 4 plus 1 5, plus 7. Yes. Now 44 times 7, we can do the multiplication simply. 44 times 7. So this is 308. Then we have divided by 3. Now on dividing 3, what you'll get? We get 3106. So you got 306, then you have 2. So 102, 2 by 3. 102, 2 divided by 3. So what we got, students? We got volume of frustum 102, 2 by 3 cubic centimeters. Hence the required capacity of the glass is 102, 2 by 3 cubic centimeters, and that's your answer. Make a note. Now let's have question number 2. Question number 2 says the slant height of a frustum of a cone is 4 centimeter. Now again we have a frustum of a cone. Its slant height is given, that is 4 centimeter, and perimeters of the circular ends are 18 centimeter and 6 centimeter. Now you need to find the curved surface area of this very frustum. Let me draw it. We have a frustum. This is a frustum. Just like this. Now it says the slant height is 4 centimeter. Now your slant height, this height, this stupid height, the slant height is 4 centimeter, and the perimeters, that's the circumference of the circular rings, circular ends rather, are 18 and 6 centimeter. But natural, the bigger one would be 18 and the smaller one would be 6. 18 and 6. Now this, the circumference of here is 18 centimeter and here the circumference is 6 centimeter. 18 and 6 centimeter. You need to find the curved surface area of the frustum. Circumference, the bigger one, that is C1. Circumference C1 of frustum, that is how much? 18 centimeter. You know the formula for finding out the circumference, that is twice pi r. Now for C1, radius is the lower radius, that is the bigger one, that is r1. So twice pi r1 is equal to 18. Then you can go 2 ones, 2 nines. Therefore, R1 is equal to 9 divided by pi centimeter. This is your R1. So you got your first radius. Now another one, C2 of frustum. Similarly, you can do this for the C2. C2 of frustum is what? It is 6 centimeter, which implies that, now this is twice pi, R2 is 6, then 2 ones, 2 threes, therefore R2 is 3 divided by pi centimeter. Now that's your R2. Now after that, height is also given. Sorry, slant height is given. Slant height is slant height of frustum. Slant height is represented as L. So slant height of frustum is 4 centimeter. Then curved surface area. You need to find the curved surface area. Yes. So curved surface area of frustum. You know the formula, curved surface area of frustum. It is pi L times R1 plus R2. You can substitute, you can write pi times, now L is 4, then start the brackets, R1 is 9 by pi, plus R2 is 3 by pi. So on solving this, what I'll get, it's 4 pi times 9 plus 3 divided by pi, just like this, because there's a common denominator, pi. So you got like this. Now pi and pi gets cancelled. 9 plus 3 is 12. Now 12 times 4, it's 4 times 12, and that is 48. Now surface area is in square units, so square centimeter, and that's your answer. You can write hence the required curved surface area of frustum is equal to 48 square centimeters, and that's your answer. Kindly make a note. Now question number 3. A fizz. Fizz is a cap. Remember this thing. Fizz is a cap used by the Turks. It's kind of a cap like the Joker cap. It is used by the Turks. So that is called a fez. Now, a fez, the cap used by the Turks, is shaped like a frustum of a cone. Now, the shape of the fez is also like a frustum of a cone. So, this is a fez like a frustum of a cone if its radius on the open side. Now, if this is a cap, open side is obviously the lower one, the bottom one. The radius of the open side is 10 centimeter. 10 centimeter is the radius from the open side, and at the upper base is 4 centimeter. Radius at the upper base is 4 centimeter. And its slant height is 15 centimeter. Its slant height is 15 centimeter. This is a slant height. It is 15 centimeter. Now find the area of the material used to make this cap. You need to find the area of this material used to make the fez. Let us start here. R1 is equal to 10 centimeter. Then R2 is equal to 4 centimeter. Slant height is 15 centimeter. Got it? Then, therefore, let me first get the area. Since total surface area of fez, total surface area of fez is, you can get the total surface area by two ways. Either you can do the curved surface area of this fez plus area of top, because the bottom part is excluded. So curved surface area of this frustum plus area of top, point number one. Or you can do total surface area minus bottom. I will repeat, curved surface area plus top or total surface area minus bottom, because either ways you are getting the same result. Total surface area of fez, it is equal to, let us say, curved surface area of frustum, plus area of top. Yes. Now curved surface area of frustum formula is pi L times R1 plus R2. Then plus area of top, the top portion of this frustum is a circular part. So that is area of circle, that is pi R, but which R is there? R2, yes, pi R2 square. Now, you can take pi out. What is left? L times R1 plus R2 plus R2 square. Now put the values in. You can take pi as 22 by 7. Then L is 15. Then R1 is 10. Plus R2 is 4. Plus R2 is 4. Then you can do the square. That will give you 22 by 7. Then 15 times 14 plus 16. 10 plus 4, 14. Now 15 times 14 plus 4 square is 16. Yes. Then 22 by 7. Then you can do, let me do quickly. Now it's 15 times 14, that will give you 210 plus 16, that will give you 22 or 7, then 226, that will give you times 22, that will be 4972 divided by 7. 4972 divided by 7. Now let us have the division for this. 4972 divided by 7. So you got 7 sevens. So you got 2. Now 710, 2 by 7. 710, 2 by 7. Now it's a total surface area. It must be in square units. So 710, 2 by 7 square centimeter. Hence, the required area of material used to make fez is 710 2 by 7 square centimeters, and that's your answer. Kindly make a note. Now let's have next question, question number 4. Question number 4 says a container opened from the top and made up of a metal sheet. is in the form of a frustum of a cone of height 16 centimeter with radii of its lower and upper ends as 8 centimeter and 20 centimeter respectively. Find the cost of milk which can completely fill the container at the rate of rupees 20 per liter. Also find the cost of metal sheet used to make the container if it costs rupees 8 per 100 square centimeter. Now what it says, there is a container open from the top. Let me draw it. A container opened from the top. Just like this. Opened from the top. As in the frustum of a is in the shape of a frustum of a cone, and it's a metal sheet. A container opened from the top and made up of metal sheet rather is in the form of a frustum of a cone of height 16 centimeter. Our height is given, that is 16 centimeter. Height is 16 centimeter. Then with radii of its lower and upper ends as 8 and 20 respectively. So radius here is 8 centimeter. Here is 20 centimeter. Find the cost of the milk which can completely fill the container at the rate of rupees 20 per liter. Now that means we need to find the volume of this. By volume we'll get in, we'll come in liters, then we can go accordingly. Now let us see how. Here R1 is 20 centimeter, R2 is 8 centimeter, H is 16 centimeter. Yes, then we can find L. Let us find L here. For L you have h square plus r1 minus r2 whole square under the radical. This will give you the slant height of this frustum, and that is, let me write here, h is 16, so 16 square plus r1 is 20 minus r2 is 8, then whole square. So you have 20. So slant height is 20 centimeter. Then we can find the volume. Therefore, volume of frustum. You know volume of frustum 1 by 3 pi h times r1 square plus r2 square plus r1 r2. 1 by 2, it says use pi is equal to 3.14, so times 3.14 times h is 16, then r1 is 20 square plus r2 is 8 square plus r1 r2. Now let me solve this. You get 400 plus 64 plus 16, that is 160, then times 16, then times 3.14, then divided by 3. So you got 10449.92. 10449.92. Now it says rupees 20 per liter. Now let me, we have, our units are centimeter, so this is in cubic centimeter. Now let me convert this to liters. You know the conversion? The conversion is 1 cubic meter is equal to 1000 liters. 1 cubic meter is equal to 1000 liters. And 1 liter is equal to 1000 cubic centimeter. Now we have cubic centimeter, that means 1 cubic centimeter is 1 by 1000 liters. So this much cubic centimeter is this much divided by 1000. So we are in liters. Divided by 1000, then we have 10449.92 divided by 1000. So we are in liters now, and that is 10.44992 liters. 10.44992 liters. Now, after that, since cost of milk, question says cost of milk per liter is rupees 20. Cost of one, in other words, we can say cost of 1 liter of milk is rupees 20. And our capacity of this container is 10.44 liters. Therefore, or I can write therefore cost for I can say this is of the order 10.5, 10.45 liters. This is approximately equal to 10.45 liters. So it is of the order 10.45 liters. Therefore, cost for 10.45 liters is equal to 10.45 times 20. 10.45 times 20, and that will give you rupees 209. Rupees 209, and that's your first answer. We have the second part of this question as well. So this is the answer for first part. Make a note. Now our slant height is 20 centimeter. This is our slant height. Our height is 16 centimeter. Our R1 is 20 centimeter. And our R2 is 8 centimeter. Just like this. Now question says find the cost of milk. We are done with the cost. Also find the cost of metal sheet used to make the container. Now you need to find the cost of the metal sheet by which this container is made. You need to find the cost of that container. If it costs is rupees 8 per 100 square centimeter, that means now we have to deal with surface area. Now get the total surface area of this container. This is your continuation. You can start from here now. You need not to repeat this part. Now total surface area of container. Total surface area of container is either, again you can do it with two ways. Number one, curved surface area of this container plus area of base, because it's open from the top. Curved surface area plus area of base, or total surface area minus area of top. Total surface area of container is curved surface area of frustum. Curved surface area of frustum plus area of base. Now, curved surface area of frustum, pi L times R1 plus R2 plus area of base is circular, that means area of circle, that is pi R square, and R2 is considered here, pi R2 square. Yes, then we can get pi out. Then we have L times R1 plus R2 square. Put the values. 3.14 times L is 20. Then R1 is 20. R1 is 20 as well. 20. Then we have R2, that is 8 plus 8, then plus 8 square, because R2 is 8. Now on solving this, what I'll get? That is 28 times 20 plus 64 times 3.14. That will give you 1959.36 square centimeter. And what is this? This is the total surface area of this container. Now I'll write here. Now let me write it here. Now, or you can write, since cost of metal sheet first you can write here, therefore area of metal sheet used to make the container, area of metal sheet used to make the container is 1959.36 square centimeter. Since cost of metal sheet per 100 square centimeter, this is given that cost of metal sheet per 100 square centimeter is rupees 8. This is given. Cost of metal sheet per 100 square centimeter is rupees 8. Therefore, cost for this much square meter, 1959.36 square centimeter, is equal to 8 times 1959.36, and that will give you 15. Sorry, we have to convert first to unitary method, because this is not per square centimeter, this is per 100 square centimeter, which implies that cost per square centimeter is equal to 8 divided by 100. And that is how much? 0.08. That is rupees 0.08. For 100 square centimeter, the cost is rupees 8. For 1 square centimeter, cost is rupees 0.08. Therefore, cost for this much, 1959.36 square centimeter, that is equal to 1959.36 times 0.08. Times 0.08. So you have 156.75. Now you will get 1959.36 times 0.08. So that is rupees 156.75. 0.75, and that is your required cost, because this is the cost for 1959.36 square centimeter. So that's our required cost, because question we were told that the container is made up of metal sheet. Now area of metal sheet is this much. Now for per square centimeter cost is this. So this much square meter cost is rupees 156.75. Hence, the required cost of milk and the cost of metal sheet is rupees 209 and rupees 156.75 respectively. And that's it. So these two are your answers, and that's the end of question. Make a note. Now let us have question number 5. Question number 5 says a metallic right circular cone 20 centimeter high. We have a metallic right circular cone. Metallic right circular cone 20 centimeter high. The height of this cone is 20 centimeter. This is the height. That means this is a height, this is a radius. So height is 20 centimeter and whose vertical angle is 60 degree. Vertical angle means this angle. This angle is 60 degree. The vertical angle of the cone is the angle of the apex of the cone. For example, if you have a cone, if this is called the apex of the cone, the tip of the cone is the apex of the cone, and angle of the apex is the vertical angle of the cone. Now, this is a vertical angle, 60 degree is cut into two parts in the middle. Now this cone is cut in the middle, just like this. In the middle, the cut is made. Now understand one thing, when a cone is being cut, there exists a formation of two solids. One solid is still a cone and another one is a frustum. You see, first part would be like this and the lower part it would be like this. So that means one part is a cone and one part is a frustum of a cone. So whenever the cut is made in the cone, you'll get one cone and you'll get a frustum. Similarly here, the cut is being made in the middle, just like here. And a frustum is obtained. The frustum is obtained. So the height of this frustum now would be 10 centimeter. Because the total height is 20. If the cut is made in the middle, that means the height of frustum is 10. So is the height of this upper cone. This would also be 10 centimeter. Got it? Now, if the frustum so obtained is done, since this is a metal, and you know metal has a property of ductility, that means this frustum can be drawn into the wire. And when this is drawn into the wire, this frustum is drawn into a wire. Just like this. Frustum is drawn into a wire of diameter 1 by 16 centimeter. This is the diameter of the wire which is made by getting the frustum, by drawing this frustum into the wire. Now what you need to do, you need to find the length of this wire. That is the question. Let me repeat the question. Initially we had a cone and the cut is made in the middle. So that means we'll get a frustum. The height of the frustum is 10 centimeter now. Now this frustum is drawn into the wire of diameter 1 by 16 centimeter. Then we need to find the length of this very wire. Let me name this A, B, C, D, E. AB is the height of smaller cone, BE is the radius, that means this is 90 degree as well. CD is the radius of bigger cone, AC is the height of bigger cone. Now, for frustum, consider the frustum. Now for frustum, CD is R1 and BE is R2. Now let us start from this vertical angle. Remember one thing again, height, remember this point, height of cone bisects the vertical angle. Now height of cone bisects the vertical angle. Since AC is the height and this angle is the vertical angle, now height bisects the vertical angle. That means this angle would be 30 degree. Got that one? Now let us use some trigonometry here. Consider triangle ACD. ACD. Since it's a right angle triangle, and angle is 30 degree here, and side opposite to 30 degree is CD, side adjacent to 30 degree is AC, and the hypotenuse to 30 degree is AD. In this right angle triangle ACD, if I zoom it, right angle triangle ACD, we have this side hypotenuse, this side is perpendicular because this is 30 degree. So side opposite to 30 degree is this side perpendicular, and side adjacent to 30 degree is base, that is AC. Now using this triangle, let us find tangent of 30 degree for this triangle. Since tan 30 degree, you know tan 30 degree, tan is the ratio of opposite side to the adjacent side. Opposite side to the adjacent side. Now for 30 degree, opposite side is CD divided by adjacent side is AC. Or you can say to present beauty, perpendicular by base. For 30 degree perpendicular is CD and for 30 degree base is AC. So either ways you are getting CD by AC, which implies that now tan 30 is 1 by square root of 3, which is equal to CD, that is R1, divided by AC, that is 20. Therefore R1, now take this here, multiplying 20 throughout, 20 by root 3, 20 gets cancelled, so it is 20 divided by square root of 3 centimeter. Now this is your R1. R1 means this is the radius, bigger radius for the frustum of the cone. Now consider Now consider triangle ABE. Triangle ABE. Since tan 30 degree, again let us find the tangent of 30 degree, because 30 degree is also present in ABE. Now for 30 degree, opposite side is BE in triangle ABE. For 30 degree, opposite side is BE. And adjacent side for 30 degree is AB. So that means I can say two present, so perpendicular is BE divided by base, that is AB. Got it? Now tan 30 degree is equal to 1 by square root of 3 again is equal to BE is R2 divided by AB. AB is the height of smaller cone, that is 10 centimeter. So you can write 10. Therefore, R2 is equal to 10 divided by square root of 3 centimeter, and that is the lower radius or the smaller radius of the frustum of a cone. Yes. Now, let us do one thing. Let me rub this. Remember this, R1 is 20 by square root of 3. Here R1 is 20 by square root of 3 centimeter and R2 is 10 by square root 3 centimeter. Got it? Now, according to condition, the question says that this frustum is drawn into the wire. That means volume of frustum would be equal to volume of wire. According to condition, volume of frustum is equal to volume of wire, which implies that volume of frustum, you know we have a formula for volume of frustum, 1 by 3 pi h times R1 square plus R2 square plus R1 R2 is equal to volume of wire. Since the shape of a wire is a cylindrical shape, so that means volume of wire is volume of cylinder. That is equal to pi R square h. Pi R square h, or I can say pi R square L, because that's height of this cylinder is the length of the wire. Height of this cylinder is same as the length of the wire. So instead of L, H, I am writing L in order to distinguish this with the height of the frustum. Then what I can do, dividing pi throughout, the pi and pi gets cancelled. Then, which implies that I can write 1 by 3 times, now the height of the frustum, that is 10, then times R1 of the frustum, that's 20 by square root of 3, then square, then plus R2, R2 is 10 by square root of 3, then we have a square, then plus 20 by square root of 3 R1, then times R2, that is 10 by square root of 3. Like this. Then we have is equal to R square. Now what is R here? Diameter of wire. Diameter of wire is 1 by 16 centimeter, which implies that radius of wire would be 1 by 16 by 2, or that means 1 by 16 times 1 by 2. Dividing 2 also means times 1 by 2. That is the same thing. So you'll get 1 by 32 centimeter. Now radius of wire is 1 by 32. Now you need to do square. So 1 by 32 square times L. L is the length of the wire. Then you can solve this whole stuff. What you'll get? 10 by 3 times 20, that is 400 by 3, because 20 square is 400. Square root 3 square is 3, because square and root gets cancelled. So 400 by 3 plus. Same here, 10 tens 100 divided by square root 3 square is 3. Then plus 20 times 10 is 200 divided by square root 3 times square root 3 is square root 3 whole square. That will again give you 3 is equal to 1 square is 1, 32 square is 1024, then we have times L. You got it? Which implies that then I have 10 divided by 3 times, now the common denominator, so I can write 400 plus 100 plus 200 divided by 3 is equal to L once L divided by 1024. Got it? Then I can go, which implies that 10 divided by 3 times 4, 5, 6, 700 divided by 3 is equal to L by 1024. Then I have 700 times 10, that is 7000 divided by 3, 3 is 9 is equal to L divided by 1024. The next I can go 7000 times 1024 divided by 9 is equal to L. You got it? Then I can do, now let me solve this on calculators. Now 7000 times 1024 divided by 9. So I got, which implies that L is equal to 79644 79644.44. Now we are dealing in centimeters, so that means this is a centimeter. If I will convert this into meters, so I will divide it by 100. Now let us divide this with 100, so I get 79644.44 divided by 100. So I am in meters now. On dividing 100, I am in meters. Therefore, I can say L is equal to 7964.44. 7964.44 meters, and that is the required length of the wire. Hence, the required length of the wire is 7964.44 meters. And that's your answer. Make a note. See you next time. May Allah bless you all. Assalamu alaikum wa rahmatullahi wa barakatuh.